And fucking Dawson looking like a goddamn hellscape.
The Fox,
But it
what was it?
wasn't bad today.
Fox Lake fire?
Fox Creek.
The Fox Creek. That one's
Or
pretty
was that
wild.
Fox Lake or Fox Creek? They're both burning, so
It said Creek, I'm pretty sure. Pretty sure it was
yeah.
Creek.
Fox Creek's the big one that people care about. Fox Lake is like in the buttfuck nowhere, northern Alberta. Fox Lake's cutting off the highway to Edmonton from Grand Prairie, so you have to do a big detour.
Man, you got all the conspiracy theories. It's even on poll now.
That the forest
people are
fires are
crazy.
now the next like distraction.
And
The
I
government
don't-
started the forest fires as retaliation for the truckers.
the conspiracy on poll seems to be that it's Antifa is attacking Alberta through forest fires.
Oh,
Essentially.
so many Antifa members in northern Alberta.
Yeah. No, they're driving up from Portland.
I wasn't able to absorb the full autism in but that seems to be the general argument.
That's for the
is
best.
Yeah.
Some leftist group
if you
is
can,
undermining
if you get that high of a dose, you're pretty much dead.
some group is undermining Alberta because Alberta's standing up to Trudeau or something along those lines seems to be the consensus on the the telegrams, I guess, whatever the fuck people use these days.
I hope people are still using Signal. I don't want to be a boomer and have everyone move to a new platform.
I think Telegram is used a lot because it's like I have never used it, but I think it has like more of like a follow feature thing, like where you can have like
so like more interaction without people that you know personally.
Yeah, and also like more like you can follow like a prominent person or like have some, you know what I mean? Like you can have like a person that like an info source that can post out to like broadcast to a large number of people without having to like it be like one big chat. It's more like Twitter, I guess, in that way.
I've heard it's the place to go for pirating 3D printing files. Telegram.
I think it's like
Well,
Discord.
excellent technology lesson. We are live, and let's get rolling into the episode with some more technology. So today we're going to be covering 3D printing, as it's kind of a niche thing, but it's rather interesting, especially since people have been saying it's going to be taking over industry any day now. So wanted to see where those predictions are. And I think what we can do is maybe just do a quick overview of the history of it, and then we can get into the more modern stuff. Price, if you want to lead us through that.
Yeah, so 3D printing, in case people aren't fully aware of what it is the other term being additive manufacturing, which I think is a bit more self-explanatory, which is to say that you make something by adding matter to it, as opposed to traditional manufacturing methods, which are usually subtractive. So like, you carve down a piece of wood. In this case, you would take the wood and you would somehow combine it together and make the carving out of the wood fibers. So that was kind of the intellectual theory that led to the development of 3D printing, was that, making something in layers additively was a cool idea. And the first 3D printer was in 1987. And so they started with photopolymers that could be cured by stereolithography, which is to say putting light on it in a desired pattern, and then you would pull it up and put light on the next layer, and then those two layers would bind together. And the year after that, another group came up with selective laser sintering, which was putting a bed of powder, plastic powder, and then you'd hit that with lasers where you wanted it to melt and join to itself. And the year after that, you had FDM, which is fused deposition modeling, which is, if you know anything about 3D printing, probably what you associate with 3D printing, because that is where you have a spool of filament, and that filament is melted and put onto the print bed and then made in layers, layering the filament on top of itself. And the interesting thing to me, that was the big three, and they were all 3 years apart from each other. But it didn't take too long until metal 3D printing was invented, which was direct metal laser sintering, which is very similar to selective laser sintering of powders, except instead of polymers, you now, or plastics is the better known, you now have metal powders. And that was in 1994. So as far as I knew until 5 years ago, metal 3D printing didn't exist because I was apparently living under a rock. But it's been around for a lot longer than people are used to, although it certainly has come down in price to an amazing extent, which it never was before. Like, I'd imagine that 1994 stuff was probably only being seen on NASA space missions.
Yeah, like that was one of the things that, like, I just did a little bit of the history, like just from Wikipedia, and I noticed that a lot of the technology started in the 80s. I was like, oh, like I thought it was much more recent than that.
Papers were being published in the 80s. The first 3D printer was 87.
Yeah, like the printer. Well, concept started even earlier than the 80s, but
in the early 80s.
Yeah, but like the actual printers, there was the late 80s. I thought that was very interesting.
So that's kind of the brief commercial history of the technology, and then for the hobbyist side, you have an interesting project that really birthed the entire hobbyist industry, which is RepRap, which would be I forget what it's short for. Something rapid reproducing rapid prototyping. So basically, a professor in England figured he had always been interested in self-reproducing machines. It's kind of been a sci-fi trope for at least, I heard of people writing about it in the 1930s, probably even older, because a self-replicating machine is just cool. Golem that builds itself or whatever. I'm sure it even predates computers. But he saw 3D printers, and at the time they were $150,000. And he figured this was the technology that could be leveraged in order to create a machine that could create itself. So he ordered parts from the 3D printer to build his own miniature, much smaller, much less capable 3D printer, with the goal of it being able to make the parts that he ordered from the big capable 3D printer for itself. And he achieved that goal with a research squad. Around 2008, they managed to produce all of the 3D printed parts for their RepRap machine on the RepRap machine, so that they no longer had to order parts from these big 3D printers that cost hundreds of thousands of dollars. And in 2009, there was a big shakeup in the industry because that was when the original FDM patent expired, which meant that companies were able to sell FDM 3D printers commercially. So what you had was people with experience in this RepRap project making 3D printers based on the RepRap design in order to sell them commercially for a profit, now that it was 2009 and that was allowed. So until then, all of this was non-profit based. It was all hobbyist tinkering. So all of a sudden, you could buy a pre-made kit. And that was basically the explosion of hobbyist 3D printing, because you went from a 15th, like a cost comparison for one of these 3D printers, non-hobbyist commercial 3D printers, would have been $15,000 roughly, and a RepRap kit that you had to assemble yourself, it was some work, was about $500. And by 2016, those RepRap kits were down to $300, which is kind of when RepRap tailed off. At least they had a commercial side that was birthed from the RepRap project directly, and it closed up shop in 2016 because it couldn't compete with the Chinese manufacturers. That because RepRap, if I didn't mention it, was an open source system, the Chinese manufacturers just took all of the innovations of RepRap and made 3D printers cheaper. But one of the probably the most well-known 3D printer company is Prusa, and they were birthed right out of the RepRap idea, and they're still kicking as a very true to their roots sort of RepRap open source license company, and they compete on the basis of being high quality with good quality assurance, good customer service, and people want to support that sort of open source in the community as well. So they charge a bit of a premium, and the Chinese companies, not so much. And I think that's basically the state of how 3D printing got to where it is today. I mean, the commercial stuff there's a lot of weeds to go through, but basically what can be said for that is a metal 3D printer is still, you're looking at around 100 to 200,000 as an entry point, American dollars. And for sort of an industry standard metal 3D printer, you're looking at 500,000 to a million. So it's gone down a ton, but it's still out of sort of the price range of even a prosumer. You really need a good industrial use case to have one still.
You have to be more than just doing it for shits and giggles.
Yeah, whereas the plastic, it's like we're at the point where hobbyist 3D printing is pretty incredible. So
well, and is it worth mentioning? Like I saw that like there's still a bit of or like resin printing is still
that's the SLA tech, and I should have mentioned that the important patents for that went out of print in 2014, and SLA is actually in a lot of ways it's cheaper than FDM now to get into, and especially to get high quality prints from, because the current tech, which people will argue if you get into pedantics that it's not really SLA anymore because it's not stereolithography, it's LCD, but the functionally curing a resin with light is the fundamental technology. You can get a good SLA printer for $800 that will give you top quality miniatures or figures or models. If you have any notion of Warhammer or games of those sorts where people pay outrageous amounts of money for little pieces of injection molded plastic, they pretty much face an existential threat from SLA 3D printing. But the big downside that has prevented sort of mass adoption of SLA versus FDM, because SLA is more accurate, not necessarily stronger, but depending on circumstances, it can be equivalently strong with FDM, though FDM has some ability to be stronger. But your big problem that it prevents mass adoption is that the resins are fundamentally toxic, and you have to be careful and wear PPE while dealing with them. And
is this true? Isn't resin also like more expensive for like the same amount of printing, or does that come down significantly?
It depends on the resin you're using, and that's where I'm kind of out of my depth because I haven't actually personally bought one. I'm much more familiar with the FDM, but I would say from what I've seen, it's more expensive per kilo. But you also need, depending on what you print, you need more supports too with resin, so that you're wasting more material than you are with FDM. But that can vary based on the model. I would say it's almost certainly more expensive for the high quality resins, but at the same time, the high quality FDM is also super expensive, and most people don't buy it, and they get perfectly good results with low quality stuff. But I'm not sure if that's the case with resin.
Well,
Like you can buy an $80 roll of PLA, or you can buy a $20 roll of PLA, and most people buy the $20 roll and are content with that, right? In terms of FDM.
Interesting.
Would the $80 make like truly make a big difference though for certain things?
No, I think it's marginal. It's just way more dimensionally tight tolerances, and I mean you would only notice those differences if you're talking a prosumer to a professional machine. Like most consumer machines, I don't think it would make a noticeable difference because the machine's tolerances wouldn't be tight enough to appreciate it. But I'm just saying that those sort of variations in quality exist in FDM. But that's probably the logic out of there is that you get more high quality resolution of consumer grade SLA, so that you probably are more capable of noticing the difference in quality between resins.
Because I was just watching something, and basically hit the summation of the resin was that it's easier to get like your first print right. It's not that hard to like print something, and because it's very straightforward. But the other thing that on top of like the toxic nature is just it's super messy. Like
that's another good point. You want like a dedicated space for it because it's gonna make a mess.
And I think a lot of like consumers, right, would be turned off by just having to deal with something that's complete mess, making a mess all over there. So I think that's a big
Well, no,
Big
like
difference.
for instance, the printer's $600, but when I've looked into it, I've also looked into the post-processing equipment because that kind of contains your mess. But then you're looking at probably another $300 to $400 for post-processing equipment that will keep you from getting things messy.
Oh, that's another good point. About just the differences between the two. I did see that you need alcohol too to finish off resin prints, don't you? Some sort of
Depends on the resin you're working with. Some are water finishable, and many are alcohol finish.
which is another big cost input, right? Like if you're
Yeah,
doing a lot of printing, then you're buying a lot of alcohol. And I to be fair, I haven't looked that recently, but I don't think it's that cheap.
isopropyl's not bad, but I don't know what percentages you need. Once again, I haven't looked into that, but it's a good thing to bring up because I would certainly put it over the cost of FDM per part because even if the resins were the same price as the filament, then you don't have to post-process the filament.
Yeah, so lots to consider for sure. If you're
An
looking into
interesting
it.
part with that is the video I've watched that kind of did a comprehensive breakdown for people that were interested. The guy compared, he wanted an army of Warhammer figures, and it would have cost him $1,100. And he bought a new SLI printer, and he bought the resin, and he bought the post processor, and he printed off an army, and it cost him $1,200. So almost broke even on his first experience. First print in the hypothetical scenario, but obviously he was experienced.
That's pretty crazy though. Like that. Yeah, that's an industry that's going to be.
Yeah,
yeah. The models definitely seem like, and collectibles seem like such a good, such a good niche market for it.
Well, if you knew like buddies, because I'm sure there's a lot of cease and desist going out on the internet these days. But if you knew people in real life that were wanting to purchase those things, you could easily pay off a 3D printing hobby, I'm sure.
Yeah, just the one guy that's in the embedded in the community that does the 3D printing and now undercuts the retailer by 75% cost, right? Like
Yeah,
just bye margins. So screwed.
Yeah, and then you could also do a bunch of custom, like build your own, like if you're like Warhammer or whatever else it is, you can just do your own custom stuff, which would be tons of fun.
there's some amazing figures out there. I guess this also applies to the anime community because they always buy exorbitantly priced figures, and that's a big income source for anime studios. And that'll be under attack by 3D printers as well if people are really dedicated. So far, it doesn't seem to be the case, but I think once 3D modeling software gets easier to use, which will probably be leveraging AI in order to, kind of take the intentionality using AI to figure out what you want to do rather than actually needing to know how to model something in 3D perfectly. Like if you can tell the AI, turn this 2D picture into a 3D model, and then you can say, oh, the hands are too big, or you can say, oh, the hands aren't big enough, right? It's sort of
or in the case
natural
of
language.
In the case of AI, it seems to be like, oh, the hands have 7 fingers, or
Yeah, the hands have too many fingers will definitely be a problem.
Yeah,
can you go
or
can you go
big
to
spaghetti
5
ones.
and 1 thumb? Like, can you get this fixed? Like, yeah, AI is fucky with some of those humans.
It's funny because humans
things.
have so many problems drawing hands, and then AI's like, hold my beer. It can't even get the number of digits right.
Yeah, I was gonna say, I think most human, artistes that were practicing still got the number of fingers right. That wasn't.
I've probably seen a lot of. I would understand if they didn't get enough fingers because I've seen a lot of human artists with like anime styles that forget to draw thumbs, so they'll only have 4 fingers and no thumb.
Oh, isn't that The Simpsons? They have 3 fingers and a thumb.
Yeah,
Yeah, like that's a common mistake, but the additional digits is something you almost never see a human do.
I don't think it's like, I think for anime it's often like an intentional design choice, but yeah, I don't know, like just to have like less digits because it's easier.
But no, the ones I'm talking about are explicitly where artists are like called out for the fact that they missed a finger, and they're like, "Oh my god."
Oops.
well, we're getting a little off track, but
Maybe the training data is garbage. That's why they fucks up. Well, I think we're gonna go into the more commercial side of things, because you were talking that's been, I think the promise of AI was always
3D
you know
printing.
yeah, sorry, yeah, 3D printing. Well, AI too. I think like the big promise of 3D printing was like the manufacturing side of things, the commercial side of things. I think like the home use was always kind of a sideshow, right? For a lot of people.
Yeah, like the developers, like one of the reasons that the rep wrap was such a big deal was because the initial companies that patented the technology had no interest in selling to consumers. They only wanted to sell to business, and their goal at the time was rapid prototyping. That was explicitly the goal in the 80s and 90s.
Which I think looking into doing some looking into the commercial applications, that does seem to actually be kind of coming to fruition, because I think 3D printing is definitely one of the like kind of a classic technology where you see overhype. I think maybe it's kind of hard to remember, but I feel like 3D printing was like kind of hit almost like peak hype in around 2008, 2009, 2010, and like
Yeah, yeah. It's
the
like over 10 years ago. I remember
What was the
seeing.
2009 hype train when the patent ran out and the rep wrap had like kind of been experiencing success, because it was like, well, now without the patent, what can people achieve? I think was kind of the vibe.
and yeah, you saw like a ton of hype and like, oh, 3D printing is going to revolutionize the world type of thing, and then it didn't, obviously, because none of those technologies are nearly as easy to actually develop at a commercial scale and implement. I think like over 10 years later, just looking into it, it does seem like the rubber is meeting the road with 3D printing, and there are a lot of companies that are starting to integrate 3D printing into their like business, I guess, and it it definitely is helping on the commercial side of things, and it's not replacing traditional manufacturing or anything. But I think the rapid prototyping has started to like be quite prominent, where I would say most or a lot of new products are getting prototyped on 3D prints.
Yeah, the two
And
places where you would see it being most integrated into the end product are uh, aerospace, because it can make stuff substantially lighter. Like the same part will be 30% lighter, 3D printed versus traditional manufacturing,
Yeah,
and it often will be one piece instead of two or three.
that's
And then the
really important in aviation. So Airbus has been doing that for a while. Like a good example of this is their door hinges. They used to be like a multi-part piece, and they just now 3D print them, and it shaves off 4 kilos per door, and each kilogram saved is like 500,000 liters of fuel over the course of the life of the plane, which is just like astronomical. So they're always like, there's such a massive incentive to cut down weight and reduce like the complexity because of that as well. So it's just such a big boon to particular types of manufacturing to be able to put that into the arsenal as compared to like
yeah,
traditional manufacturing techniques. Like, and so there's like, in my research, it's definitely still niche in manufacturing as of like 2022, 2021, when like a lot of the stuff was posted that I found. But for certain industries, it's already a big deal,
and
aerospace
the
being
other
one of
one,
them.
aerospace is definitely the number one, and then the other one being that you can manufacture things with 3D printing that were simply infeasible before,
Yeah, I got
or
a
you
good
can do
example of
things
that
that were
as
complicated that are
well.
way less costly to do with 3D printing.
Yeah,
But go ahead.
there's a company on like a channel on YouTube that does a bunch of this stuff. They're like a CNC, like they're like a manufacturing company, and they create this amazing piece that is a fluid mixer and heat exchanger in the same piece. And you can never do the like the design that they're doing. Like you cannot mix those two. You cannot actually build one that contains both. And it's because it's a bunch of intricate tubing layered
Hmm.
inside other intricate tubing, and so it's quite a it's quite an amazing piece. Like theirs is just like an example, but like if you needed something like that, and you're like, well, you can't be done. This can't be done. Well, then you have to find less than optimal solutions. But with the 3D printing, and to keep in mind, this was a steel part that they 3D printed, not plastic.
I think I'm not entirely certain because I saw this a while ago, but I do believe the United States is issuing suppressors with their new weapons that they're designing. People who aren't into guns probably don't even know about the United States Army developing a new gun, but basically the suppressors are incorporating 3D printer design because of the way it works with the fluid dynamics of the exhaust. So the Army, being bureaucratic, basically didn't want to have suppressors because the suppressor increases your pressure at the muzzle and it'll cause more gas blowback, and then breathing in that gas over 20 years while you're in the Army or 15 years while you're in the Army increases your rate of cancer. So they needed to design a new style of suppressor that would wick that blowback forward rather than backwards while still being a suppressor. And I believe they did that using 3D printing. But in terms of practical use, I think the most common place where people encounter 3D printed parts would be automotive, at least with Volkswagen, because Volkswagen's been working with HP to sort of vet HP's metal 3D printing systems, as well as figure out where they fit in their assembly line. And they're at the point where there's a few components that they 3D print because it's just the best way to do them, and they throw them into all their vehicles.
Well, I think that's like the integrating like outright 3D printed parts in like the supply chain is interesting, but I think the one that will probably become the most common is just like prototyping everything basically with some sort of 3D printed design, right? Like,
yeah,
and not even just prototyping, but just like playing around with like various things to see if what's possible, what works, what doesn't work. So a lot of like manufacturing, like research and tinkering will be done with 3D printers, where it might never end up in that, like nothing 3D printed ends up in the end product, but a lot of the design and thinking and prototyping and iterating on the products will have been done on 3D printers.
Yeah, it's definitely getting to the point where it's a fairly trivial cost from a corporate point of view to have a 3D printer that can simply create any model that you've made on a computer. Like, it can bring it into reality. And it's like these companies are already modeling on computers, so why not?
Yeah, exactly. It's like
bring it into reality.
You can just throw it up, especially if you have a pretty quick printer. You have it done by the end of the day, depending on what you're doing, right? And then you can fiddle around with it, and like it really helps to work with things in real, like in with your hands, right? Like, just I find that has always helped versus just looking on it like from on a computer screen. I think that actually is a really big deal.
Goggles.
Huh?
And then you could handle if you put on metaverse goggles, you could handle the virtual object with your hands.
Shut up.
Is metaverse still a thing? Jesus Christ.
It's $1 billion loss strategy. That's what it is.
You definitely just caused like one person to commit suicide from hearing.
But I think there will also be what would you even call it? Almost like a cottage industry sort of revival, because from what I'm seeing, in terms of plastics, metals, it's still up in the air. But in terms of plastics, from what I'm seeing, if something can be manufactured like as an end use part with FDM, it pretty much only becomes viable it is viable to 3D print it at up to 100,000 parts, and then it's becomes a sort of a gray area between like 100,000 and a million, whether you want to do 3D printing or injection molding. But that's sort of up to 100,000 parts. You're going to have a cheaper product if you do it with 3D printing than if you do it with injection molding, because injection molding is kind of another a classic manufacturing thing that most people don't think about, but it costs an enormous amount of overhead, like hundreds of thousands of dollars for a mold that you'll then inject plastic into and it'll create your part. Whereas a 3D printer is now, for a small part, maybe $10,000 for a commercially like reliable, high
Yeah,
quality one.
but there is
Maybe
a pretty big
5,000 for a cheaper one.
there's a pretty big problem with that in the way that the economies work, right? Because once you get that mold set up, and if you need quite a few parts, like let's just say you're making some plastic doodad and you need lots of them. Yes, it costs a lot to get that mold set up, but then you can just pump those things out like crazy. Whereas with the 3D printing, it takes quite a bit longer to produce one part as compared to the traditional method. So that is where, like, because I was watching like industry videos of it,
Well,
and that was one of the major complaints.
100% what Price was getting at,
Yeah,
right?
that
It's
is the
like
point I was saying. Is 100,000 seems to be that cutoff.
you have your large fixed cost and
Oh,
upfront
that
cost
okay, I see. Yeah, yeah,
on the 3D on the injection mold, and so if you're making less than 100,000, you might not want to bite that bullet of getting the injection mold because you're just not making that many.
yeah.
But as
If
soon
you
as you
just
start
need like a
making
few, yeah,
and and I think Price was saying like that's why you might see a bit of a cottage industry for certain like kind of niche and weird products that would have never been made before because there's not going to be over 100,000 demand for that product, right? So it would never get made because it wouldn't be worth the time to go and get an injection mold done and then start running them off. But now, even if there's something that only will sell 1,000 product or 1,000 units, it might still be worth it if you can 3D print that product because you can still make money on it because you don't need to go and do some big expensive upfront cost,
The big
which will be
example,
interesting.
yeah, the big example there is for obsolete repair parts. So say you need a piece for an old vintage car, which would be a common use case. There'd be a couple thousand people with that vintage car, and it just doesn't exist anymore. There's no OEM who has injection molds for it, and no one's producing it. Now it's 3D printable. Somebody's going to make money off of selling that in the near future because there's going to be enough demand to make it make sense. And also, you don't have to carry inventory. Like if you really messed up and nobody wants this 3D printed car part except 5 people, like you wasted a bit of money on design time. That's it.
Yeah,
yeah.
you can made to order parts, right? And you can do it down to like the quantity for certain things. I'm sure you'll have people willing to pay for the one part at a, like I think that's a great example of like a classic car. They might be willing to pay you, 50 times what that part's kind of quote unquote worth in terms of what it was original cost or whatever materials just to make that part to finish their build, right? And you make
Well, like
money.
for instance, say the original part's worth $50. On a 3D printer, that part will probably only cost you $4 or $5 to make. So you sell it for the same price as the original, which they'll be happy to pay. You've just got a $45 profit margin.
And you could sell it for $500 and a lot of collectors or whatever would pay it, right? And it's pure margin. And I mean, to be fair, like you would probably have to do design and stuff, so you might not be the materials is only part of the equation, right? Like the overhead of your designing and all that other stuff. But yes, there's going to be profitable transactions for all sorts of low quantity products, right?
The design field is going to be so interesting. It already is because people have bought designed 3D scanners with LiDAR, but like iPhone is incorporating LiDAR now. And I don't know if I haven't seen anyone using it really in the 3D printing space right now, so I don't know if it's quite accurate enough yet. But it will only be a few years at most before people can just pull their phone out of their pocket, scan something in the real world, and at the very least input that geometry and then make it work for a 3D printer.
Yeah, I'm no expert, but I think like you're gonna have a convergence of scanning technology, AI being able to like take those scans and those data inputs, right, and create a viable 3D print design without that much, effort. I think that's going to be big. The big part that AI will play is like translating the scan data into like actual action because they'll have to be algorithms that where to put the supports, where to put the how to ensure and structural integrity and all that stuff. And right now, you need quite a bit of. It seems like you need skilled workers to basically do that, right?
Yeah, like right now, like if you're doing it as a hobbyist, you can afford some fuck ups and stuff. But yeah, like there's definitely a skill to just making a 3D printer run properly. But an AI, like AI learning, they're already getting to the point where they're throwing in cameras, and it will attempt to detect various problems rather than fatal errors. Like the fatal error detection already exists. They call it spaghetti. It's once you miss a print and then your filament starts spaghettiing because it's no longer connecting to the previously laid down filament. And the AI can already pick that up off camera. But they're working on getting it so that it can determine the quality of the print and what settings might need to be tweaked in order to improve it, which would just make the whole process incredibly simple, much more like an inkjet printer where it should just work.
Well, and then the scanning and design phase would also be like AI assisted, right? Like you could imagine a future not that far off where you take your iPhone out to whatever you need to replicate or whatever. You scan the thing, you input it into a program that automatically designs a print plan, and then the printer is assisted and kind of self learns how to most optimally print that product, and within a few runs you got like a more or less perfectly printed object with minimal skill input from the user, right?
Mm-hmm.
Because I think that I was just looking through it. It seems like right now one of the big bottlenecks to commercial viability for 3D printing in terms of manufacturing and stuff is just like a lack of skilled workforce capable of like scaling up.
It's still such a hobbyist pursuit for most people, and like it doesn't seem like that's often making the leap from hobbyist to professional. Like there doesn't seem to be a stream for that yet.
Well, and it's because it seems like it's kind of, I guess, mostly in the domain of some sort of engineering, materials engineering, and that's already like seems like a pretty what would you say, like behind in terms of a number of people already. For like engineering is already a super in demand profession with shortages of workers, and this is just another thing.
Well, this is like a combo of material engineering and software engineering, basically. It's like
that's definitely going to be like that. In one of the videos I was watching, that they said that's going to be like a pretty good niche education to get, because there's going to be a lot of room for growth in that.
Till the AI takes all the jobs.
Yeah,
has it all figured out.
But then we get to live on Goyslop and do nothing. It's going to be perfect.
Well, I think like AI and just technological advance will be a big part of making it actually viable, right? Like I just don't think we're going to ever get to the point where we fill those quote unquote shortages before we fill them with essentially artificial intelligence thinking power. Like,
dumbing down the machines is easier than teaching up the people.
Like, especially in the time frame like that people want to, that I think there's enough pressure and enough money in it that the time frame will necessitate people looking to dumb it down significantly.
On like the corporate side, the United States at the very least, I'm sure other governments have been doing it, not as publicly, have been dumping money into 3D printing and grants for 3D printing. So there was one initiative that I thought was really interesting in the United States where they gave them a grant for, I think it was like $6,000 towards a 3D printer for their business, but they had to be signed up to this like network that would 3D print emergency materials in the time of crisis or something, which it actually just sounded really cool to try and encourage these small businesses to actually have 3D printers and sort of fool around with them and try and figure it out, because they obviously view this as strategically important in the future, as like being on the cutting edge of the 3D printing industry, because that's going to really change how people do things on a local scale at the very least, but probably even on a like fairly macro scale, with all the ability to just avoid supply chains. I think is the biggest thing the United States is concerned about.
Yeah, so like kind of give it like a quick like a lot of the touted advantages of 3D printing and why people in certain areas have been pushing it so hard. these touted advantages, like they are real, and if we can figure out how to do this technology at the quickness and cost that makes sense, is like they're pretty huge. Like one of the main things is you do remove a lot of supply chain vulnerabilities, right? If you can just print a bunch of the stuff that you need right in your local area, you don't have to have it shipped in from China or from India or wherever else it might come from. You can just print off the part. Like say for instance you're running a mine, even if it's in like you have the parts in your country, but you're running a remote mine, you just set up some 3D printers there and you just print what you need. You don't have to have it shipped all the way from like a population center into the mine. So it really does cut down on those vulnerabilities. And it also reduces your shipping costs, right? Like you don't have to worry about if you just need a new.
I think like in my mind at least, like that's the biggest advantage of 3D printing in terms of like strategic supply chain is like the potential to make things, not the actual making of them. In the sense like, if you can develop the potential to 3D print, say like whatever your top 100 strategic resources or manufactured goods, you don't even need to have them being actually manufactured with 3D printing. You just need to have the 3D printing capacity.
You can just fire up the machine when you need it.
And so then you can still source it, if it's still cheaper to source it from China because China's subsidizing the ever-living shit out of the industry or whatever, and it's just, then why not just keep buying it from China? As long as you have the option to quickly turn on production in your own country or a strategically friendly country. I think that'll be the big thing, because it'll be very wasteful to try to like 3D print all these strategic goods, but just having the ability to print them and having the capacity there means that then that's a backup.
Yeah, from the strategic like national defense point of view. But again, like even like looking at it from like a more local like company issue, I gave the mine example. If you somehow break something that you don't actually have a readily available part, you can just fire it up, print it off, and then you can get if it's a bit more of a higher quality part that is manufactured elsewhere, you can then get it and just keep rolling with the 3D printed part as you wait for the next one. Or maybe the 3D printed part is good enough that you can just keep going until it breaks and you can print off another one and keep going, right? I've worked with mines, and I use this example for a reason, just because it's like, if you some of your equipment gets damaged and you do not have you can even 3D, like especially combine that with a scanner, like the scanner technology. It's like, oh, like this part broke, and we could jerry rig a fix until something more permanent can be done. Like that can really save your production line.
Well, and that's like the same example as the country level thing, just at a shrunk down scale, right? Where it's like you're not going to be manufacturing your mining equipment with 3D printers, but you're going to have a 3D printer on site as a backup.
Exactly.
In case any one thing breaks, and you don't expect it all to break, but one thing that you can't anticipate will break, and therefore you have the capacity to immediately turn on a printer that prints that one thing, and then you're good to go while they build a replacement at the original factory or whatever, and get it to you in a month. And it's,
I think the sexier examples than mines are aircraft carriers, where the United States Navy is now putting 3D printers to see if they can cut down on how many replacement parts they have to carry. And then of course space, because you are going to need a million different things in space, but you don't know which million things you need, and you definitely don't want to be carrying 10 million things when you only need a million.
Yeah, oh yeah, for sure.
You can replace a whole cargo hold of parts with a couple rolls of materials, right, and a printer. That's
or a whole cargo hold of materials, and now you can do 10 times as much, because they'll never just be useless.
True. Yeah, you can go 10 times longer without resupply or re-upping on your.
Which is, I guess, in the mine example, instead of having to bring in like a shipping container of frequently broken parts, you just bring in a 3D printer and print the parts when they break.
Exactly. Yeah.
Because especially when you're dealing with like more remote. The reason I gave a commercial example is just because military is a whole other beast, right? And
Well,
it's about
aircraft
getting
is so
the
cool.
in like general industries on board. Though, like
The
the
aircraft
military has.
carriers, like,
Sorry.
well, like the aircraft carriers, because they're basically a floating city. Like in the Second World War, the Americans figured out they just strapped planes to the ceiling of the hangars and the aircraft carriers, so they couldn't utilize them, but they knew they'd lose enough planes that eventually they'd unstrap them from the ceiling and still have a full contingent of planes to sort you out. And like this is just like the next step of that, where like the Japanese hadn't had that figured out, although they were operating closer to home. But aircraft carriers are such an amazing feat of human engineering. I think
Yeah,
there's
those
like
things are nuts.
5,000 people on
Literally
them.
driven by a nuclear reactor.
Insanity. It's literally a city. It's just like floating in the ocean that can wipe out most countries.
Well, Canada for sure.
Yeah. Oh, we'll get our F-35s one day.
Yeah. By the time, I don't know, the new jet's out,
Yeah.
they'll retrofit some American F-35s and then sell them to us as new.
New old stock.
Yeah, that's the only thing we're getting. It's like Chinese GPUs that have been mined on for 5 years and then ship them over to North America as new stock.
Yeah.
Problem solved.
Easy peasy.
Yeah, I don't know, the other commercial application that doesn't use plastic or metal, uses concrete, was houses, which I thought was very interesting because it seems like it's still at the beginning, but there's actually been several projects done in various areas with 3D printing homes. And I think it definitely following along the same lines as 3D printing itself. There was a lot of overhyping 3D printed homes, especially I think the one that I actually saw, and I didn't even remember these marketing campaigns until I started rereading and re-researching some of this stuff, was like we'll 3D print homes for like, developing country people in developing poor people in developing countries, and it'll take, we'll bring in a 3D printer and we'll print 1,000 homes in, 2 weeks, and it'll cost like, $12 a home or whatever. Like these crazy outlandish claims of like being able to like print whole countries worth of housing cheaply and easily. Those seem to have like died down a lot because it just hasn't seemed to be accurate and pan out that way. But now they're actually starting to use 3D printing for homes in like North America and developed countries, and just based on what I've seen, like they do a as good if not better job than traditional like builds, and they definitely do come in at a price point that is competitive with conventional home building. And from what I can tell, you'll pay the same price for a better quality home, essentially, with 3D printed home, is what.
Yeah, that's what I saw, but I watched the same documentary as you about it, so potentially a little biased. But I mean, building a home out of concrete intuitively seems like it's going to be sturdier than a stick-built house, for sure.
Well, and I did go and look up some of like the places where you can buy them, and it does seem like they do legitimately sell at the same price point or slightly lower in those markets than conventional builds, and they just are legitimately better quality. Like it's hard to argue that with like the just like the efficiency ratings they get and the strength and durability of the homes that are made. To be fair, maybe it's a bit of a con job, and in 10 years some of them will start falling apart. Contracting and home building is full of chicanery and bullshit, so it is probably too soon to tell for sure. But just based on like what they've been certified for and qualified for, it seems like they are delivering better quality homes at similar or maybe even slightly lower prices at the current moment.
Probably the thing that would be most interesting is if they had managed to hoodwink NASA, because they have a NASA contract to develop cement that will work on the moon, and with their 3D printing technology. So hopefully it's they haven't managed to pull one over on NASA and just get get away with billions of
Yeah,
taxpayer
when
money.
NASA's down in Texas looking at the neighborhood, the concrete neighborhood that's falling apart, and just looking at their Mars installation, going, "Oh shit,
Yeah.
fuck, oh buddy, that's not good." Like, and the contracting companies like gone through 3 bankruptcies and 3 new shell corporations and can't even get a
Now they're
hold of
based
them.
in the Virgin Islands.
Yeah, guys moved to pieced out of the United States. Yeah, that's not going to be a good look, but hopefully it doesn't go down that way. And the other interesting thing just to note there is like, from what I could tell, 3D printing homes is still it's viable now, but it's promises to get better in terms of both like the quality and complexity of builds seems like it's going to ramp up just as they get better techniques and materials and scale, but also the cost. I think the big cost savings still to go is labor, because the plan, like, from what I can tell, this was several different 3D printed home companies that I see. Their current model is to have like one person running the printer, one person running the feed system, and then like 1 or 2 other people like doing quality control or like kind of supervision. And they're all looking towards bringing that number down to like 1 person per site or less than 1 person per printer. So like in a neighborhood, you might have say 10 printers printing homes, and you'd have 5 people, 5 workers on site running 10 printers. That's kind of like their goal. And right now that's more like 40 people running 10 printers. So, and that's still a huge component of the cost of printing homes is the labor. And with I think that realistically that will go down, maybe not as fast as they want, but it will go down. And so 3D printing homes only seems to promise to get cheaper than current. So I think it's kind of promising that they're able to offer something in the neighborhood of competitive with conventional builds already, and they definitely have a lot of runway to go in terms of bringing costs down.
Another interesting part that they were discussing is that with the 3D printers, they could theoretically run 24 hours in a day, but that currently the municipalities they work in legislate the hours at which construction work can occur to be, 10 or 12 hours a day, depending on the municipality. So they could get twice as much work done as they're currently getting done if they just got the legislation changed, which they'd kind of have to prove the decibel ratings aren't so bad, but at least according to them, the decibel ratings are pretty much ambient noise in the whole neighborhood around them.
Yeah, I think there will be definite builds that will get approved for 24 hours, right? Like it might not make sense everywhere based on how the proximity and stuff, but for sure there will be builds that could, like if you're in a brand new
Neighborhood, yeah.
yeah, like your brand new neighborhood that's not near fucking anything, and then yeah, I'm sure you'll get 24-hour approval, and like you said, they can easily run 24 hours. There's nothing stopping them. The machines don't need much. Like I think they need some soft downtime every once in a while for cleaning and stuff, but they very minimal. They're very much capable of 24-hour operation already.
Gonna have more houses than we know what to do with in no time.
Yeah, well, Canada, they'll need them. Just
No, we
strip
don't
out
need
all the
'em
fields
because
in Vancouver and the
the last thing we want is our housing market to crash.
well, last thing the government wants.
To be fair, Canada doesn't have a Canada. I mean, I'm sure it's viable everywhere, but for Canada, it's like it's not the houses. It's the fact that everyone wants to jam themselves into 4 square kilometers in Ontario and 4 square kilometers in Vancouver.
True.
Yeah.
Plenty of cheap houses outside of those areas.
And yeah, cheap land to build houses on. But yeah, I guess maybe if you're tired of the whole Canadian housing bullshit, then you can buy a cheap piece of land in the middle of fucking nowhere, and you don't even need like a whole skilled crew to come in to do the bulk of the build. You get it might actually make it easier to build. I guess what I'm saying is it might make it easier to build decent quality homes in kind of more remote and far-flung locations, because you don't need the skilled labor force anymore that is required, which can be like basically impossible to source in a lot of the more like remote areas
Mm-hmm.
in Canada, and I'm sure the US is the same, right? Like some small town or rural area, it's just like you can't get a building crew for any amount of money pretty much to come out there. It's impossible. Now you don't need that. You might get to a point where you might be able to run the thing yourself. You just rent the machine and cost you 50 grand to get up your.
Man, it's a good thing nobody's listening to this because this sounds like a commercial plan. Gonna have to run this one by the old boys.
The 3D print company.
Yeah, we're gonna buy a 3D printer and we're gonna rent it to people and they can print their own house.
You wouldn't print a house, would you? You wouldn't download a home, would you?
Absolutely. Just try and stop me. I know how to use VPNs.
Another cool thing with the 3D printed houses that's just simply aesthetic is the ability to have organic and curves, sort of, feel more like a natural sort of shape rather than it all being rectangles. And of course, I'm pretty sure they offer a bunch of rectangles, but people are going to take them up on the organic shapes when they're getting a bespoke house, and you're going to have a lot more interesting looking houses potentially.
Yeah, I was looking at some of the designs on the one company's site, and their new build, I think it's in Arizona, has a lot of that, like a lot of circular buildings.
Yeah.
And it definitely does work, at least in my opinion, like aesthetically and just like they look really cool and definitely not easy to replicate with conventional building methods. And
Man, there's nothing contractors hate more than a stick-built house that has curves. Like that will just that'll cause aneurysms for sure.
What's that? Sorry,
Yeah.
I missed that.
Contractors and stick-built houses with curves, like your traditional 2x4 framing.
Yeah.
You don't want to see a contractor exposed to that.
start seeing
Just
smoke
can't
coming out of
handle
the
it.
ears. Not having it at all.
Our whole society is built off of rectangles. These bookshelves, these beds, these couches, they're all rectangles. We need a rectangular house to maximize the space efficiency.
The other cool thing with 3D printer home stuff is they print a lot of like can print like kitchen islands, like planters, like all sorts of other like kind of accent things that you would normally you might be able to get for like in concrete. You don't need to, because on site you can just get it all printed at the same time, right? For pretty low cost. It's just the equipment's already there, so you can get it all added in, which I don't know. I'm sure they'll be able to iterate on that stuff too, with as they get better and materials. And
It's just way cheaper to have a concrete pillbox guarding your front entrance than it used to be with 3D printing.
Yeah. Now everybody can live in a World War II bomb shelter. Man, all the fucking Victoria autists are gonna be spurging out for this. Or not, sorry, Hearts Firing guys. Be like, oh
yeah.
yes.
I thought you were meaning the city Victoria because it's going to collapse from an earthquake, and then they'll all have the opportunity to get 3D printed houses.
Who cares what happens there?
Yeah. Do we got anything else to shovel in on the 3D home?
I didn't have much on it at all, so no, not on my case. I think it will be very interesting to see it develop. The one thing I would say is like the home, you're kind of stuck. Like when I did check out a couple of the videos that you posted, and there was like a commenter saying like you're kind of locked into the home build once it's built because it's concrete. Like you're not going to start hacking out walls and remodeling. So, like if you're doing slots for your appliances and whatnot, like you are somewhat stuck with the model that you get, and that would be like the one kind of downside. But I think you'd probably have to understand that going into it, and if you're okay with that, then like who cares? But
I think my estimation would be that it'd pretty much be a wash in terms of resale value because you have like the higher quality home, but you have that inability to modify a bunch of stuff.
Yeah, like you get the nice like watertight really structurally sound house, but you're not going to remodel it, and you just have to understand that that's what you get.
But like if you're buying an old house, I'd way rather be buying one that was made of concrete.
Yeah, oh yeah, for sure. I think that's like the one thing that some people would have to consider when purchasing the home, and that's
Yeah.
fair enough. But there's downsides to everything.
I think there would be a bit of a learning curve, like in North America, for that
Yeah,
because there's been just such a long history of just building fucking wood framed builds, but in like
yeah, because
lots
quite
of
a
parts
few
of the
people
world,
do rent out their homes. Like that's
lots
quite
of parts of the
common.
world, concrete and brick is like the only thing that's
Go-to.
used. So like
Yeah,
it's just would not like for like yeah, that's a very North American kind of concern, I guess is what I'm saying. It's like lots of places in the world like this would be no different. It's just like a different way to do concrete construction. It's just more of a revolution in North America because we don't use concrete pretty much ever for home builds, which I mean, yeah. And I guess the last thing I was like would throw in there is like there's some people are making an argument about like 3D printing homes also being like I guess this is like the trendy thing is like supply chain resilient because all you need to make them
the concrete.
essentially concrete, which is pretty easy to source. It's pretty ubiquitous material. I don't
Unless
know
China
like
sucks it all up.
the homes I was
Well,
looking
you make it
into.
all in country, right?
Yeah.
You're not getting concrete from China.
The homes I was looking at do still have like a decent chunk of like obviously steel product and wood product, as finishing materials and accenting materials and framing materials and like the roofing was like all the roof framing was done with wood and stuff. So it's like yeah, it's definitely cuts down on the reliance on those products, but it's not like gone. So it's I don't know.
Well, I'd have a question about how reliable the concrete or cement production line is as opposed to wood. For instance, like with the wood supply chain and that huge spike of wood during COVID, that all was pretty much a result of 2008, where 2008 to this day was the greatest wood output America's ever had. Wood meaning lumber, like processing it through the mills and actually producing dimensional lumber. And then after 2008, they shuttered, I want to say it was like 30% of the mills in America, and they've never reopened those. Although it was actually the first time they'd opened new mills since 2008, I believe, in America on aggregate. When you take all of America, it was the first time they had a gain in mills since 2008 was 2020 when there was all that demand. And I don't know, like it's a relatively inelastic system because when they got rid of that supply, then it takes a lot of work to build it back up in America with lumber. But I'm not certain how cement compares to that. If you say cement's going to be 50% of all new houses, do they even have the ability to produce that much cement in America?
Yeah, that's another concern. I mean, it's like anything else. Like, I'm sure it'd take time to scale up. To be fair, I think 3D printing homes will scale up slower than, like, it won't scale so fast that it'll outstrip cement supply, would be my guess, but I'm no expert.
Well, it kind of depends, I would say. Like, in principle, it shouldn't, but I would say it would depend on who's in the White House there and running their green initiatives, because concrete is, like, directly in the sights of the Greens. They really don't like concrete. It creates a ton of pollution. And also the ability to come up with a green concrete, like Bill Gates is pouring, I'd imagine, millions, if not billions of dollars into that sort of technology.
Yeah, that's fair.
So it's kind of a weird
I guess that, yeah,
tangent.
that really gets into the nitty gritty of the political bullshit that goes on with
America.
the industrial side of America, whereas, I mean, every country has it, right? With all the special interests that just constantly squabble over trying to get their biggest piece of the pie that they can, right? Which, not shocking.
So I think that covers most of what we looked up for commercial.
Yeah, it's much more the hobbyist now.
Yeah, so I kind of touched on the hobbyist earlier when giving the rundown there, but it originated with that RepRap project, and a bunch of guys started off just building their own printers because you couldn't buy them because of the patent situation. And those guys, some of them went and started companies that sold printers based on the hobbyist tinkerings. And I would say there's kind of like the two streams of 3D printer hobbyists, and the ones that originally came up with developed all this rep stuff, they'd be the tinkerers, the guys who 3D print things for their 3D printer, and they buy a 3D printer to work on the machine to make it work better, but they're not really, they might print stuff that has like end use applications outside of 3D printing, but their genuine hobby is working on their machines. And then there's also the category of people that are more interested in the end use. And those people have basically been, it's like a mix and gradient here where the tinkerers are becoming less and less a share of the population that 3D prints, as the 3D printers have become so much easier to use. And that's been basically the direction it's headed over the last 15 years. Where in 2008 or 2009, you're pretty much buying a parts kit and putting it together yourself. And in 2022, if you're buying a parts kit and putting it together yourself, you are hardcore. Like, that's no longer the norm, let alone the only option. Most people are starting with a cheap Chinese printer, and then they're like, that's a pain. I don't like doing all this work. And then they buy a more expensive printer that they don't have to even work on, and then they're happy with it. Or they're buying a cheap Chinese printer and upgrading it a little bit so that it can do what they want, because they find that cool, but it's not like their sole focus. And the latest, greatest 3D printer, which I guess is fitting to talk about now, is the Bamboo Labs X1 or X1 Carbon. And that came out a year ago now, I believe. And it got the Time Invention of the Year. And it pretty much shipped in the box. You pull it out, you unscrew a few things that secured it for transit, you plug it in, and you go to your computer and you tell it to print, and it just works. And that it's almost full end on the consumer. There's a huge tinker community that also enjoys it because it's fast, and they've made some mods for it, but very few compared to other printers that came before it. And none of them necessary, more just a couple small quality of life mods that exist.
Yeah, that. I mean, you're much more into the consumer end of things, but that seemed to echo what a lot of what I was seeing on, YouTube and stuff, is like a move towards like the accessibility and the polished product that just works for the person outside of the box. And like, I haven't 3D printed, so I don't really understand it at all. But one of the things that seems like a really big deal is like the auto leveling and stuff.
Oh my god. Yes, I like it. Leveling is the biggest pain in the ass. And I mean, I started with a semi-automatic bed leveler because I knew I wasn't a tinkerer, and I started off with a Snapmaker 2, which is exorbitantly expensive because it's a 3-in-1 and it doesn't do anything particularly well. But I wanted to try out the laser cutting and the CNCing and the 3D printing. And so it has a semi-auto bed leveling where you have to level one point of the bed, and based on that, it'll level the rest of the bed. And then I got an Ender 3 because they're super cheap, and I wanted to see what it was all about. Now that I was trying 3D printing, I thought it was cool. And you have to level everything on that. And I mean, it took me way too long because I was completely new to it. And I never got that Ender 3 working properly after about 40 hours of tinkering on it. And I just eventually gave up on using it. It just wasn't enjoyable. Like, I'm not a big tinkerer, and that's kind of what you have to be to get those things working. Although, I mean, it printed well enough that if it was my first printer, maybe it would have been cool, but I had a much better printer right beside it that I could be using. So it collects dust now.
Well,
That's your X1, right? That's not
No, I got the X1 now, and now they both collect.
Yeah, okay, so yeah, you got three. That's right.
3, because the X1 prints 4 times faster than the Snapmaker and more accurately.
And just to explain the leveling, like, so, because like how a consumer 3D printer works is like there's basically a flat surface, essentially, right?
Yeah.
And that's what it's like a little laser, or not laser head, but like
extruder.
Head that like a I guess the closest thing for like a random person would be like the head of a pen, right? But bigger. That's just spitting out the melted plastic in layers, on the flat surface, and the reason you need it to be really, really flat so that it doesn't every layer is the same in the horizontal plane, right? If I'm understanding it correctly.
Yeah.
And if it's not really, really fucking flat, then you get the problem of it screws up the print like really badly. And so that's why you need to level everything very, very carefully. And a lot of the new ones, you just put it down on a desk or whatever, and then you just tell it to level, and it has like a mechanism where it can sense how it needs to adjust. Like I guess it has like some sort of like adjustable foot mechanism on each corner or whatever, right? And then it adjusts itself to get down to a
with the manual flat. You're screwing a thing on. There's usually four, sometimes three, because three's the minimum you can get away with. You'll screw a knob to level it yourself. But yeah, it'll automatically screw those knobs on the automatic bed levelers or the semi-automatic ones. The semi-automatic ones also automatically screw the knobs, but you have to set the initial level, tell it where level is, kind of deal.
Yeah, and I've seen a lot of people basically say like the automatic level is like a godsend, like in terms of just being able to actually use the printer as like.
Yeah, I can't imagine like fumbling around trying to level it manually. It'd be so frustrating.
When I got the Ender 3, basically the number one recommended add-on for tinkerers, which I didn't get because I'm lazy, was BL Touch. And so that's a separate type of leveling, automatic leveling, where it would test your bed and it would make a map of the bed, even if the bed wasn't level or was warped, and then it would adjust as it went over, right? So that it was still the correct distance from the bed when it was printing the first layer. Because the biggest issue is the first layer, and if you get a good first layer, then if you're half a millimeter short on one side versus the other side, you're probably not going to really notice in the end product with hobbyist stuff. So there's sort of that cheat code that they came up with that you could make any 3D printer auto level for like, I think it was like $50, but it wasn't as nearly as fancy as these new ones that come out of the box like it.
Yeah, so I think that, like, just me personally thinking about getting into 3D printing, that would have been, I'd definitely be falling in the camp of like the person who just does not want to deal with any of that shit, right? And just wants to buy something, take it out of the box, and like that evening have it more or less ready to go. You know what I mean? Like, just, really...
I think it's worth mentioning that sort of the first company to nearly achieve that, while also catering to the tinkerers because they were free and open source, was Prusa. And Prusa's Mark III was pretty much the gold standard printer. Like if you didn't want hassles and you wanted to try out 3D printing, you got a Prusa Mark III for about 5 years. Like it absolutely dominated the market. And then if you did want hassles, you got an Ender 3, which was basically a very cheap but acceptable level of quality control, although you still got lemons made out of China that knocked off the Prusa Mark III. But the Prusa was definitely one of the, how would you call it? The first sort of hobbyist level that was really focused on quality that wasn't breaking the bank, because, it'd be $1,000, not even, I think it'd be $850 US, but like $1,000 Canadian. Whereas a lot of the stuff that was before the Bamboo Labs, contemporary to the Prusa Mark III, for the sort of experience you get with the Bamboo Labs would have been like $5,000-$6,000, just very expensive, definitely prosumer. And the Bamboo Labs, for reference, is about $1,500 US or 2,000 Canadian, which definitely pushes the price point a little higher than the old Prusa Gold Standard. But the big thing with it is if you're practically looking at how much you can print, prints about 3 times faster than a Prusa or an Ender 3, 3 to 4 times faster. And if you really want to, and quality of the print is not a huge object, it can print 10 times faster on high speed settings. So you can get the performance out of one Bamboo Labs that you need 3 Prusas or 4 Ender 3s to produce.
I think that's also like interesting for certain applications like schools and libraries and stuff, right? Like those
Yeah.
would be the places where they might be willing to spend $1,500 on something as long as it's actually delivered a reasonably good quality experience for people actually using it, right? Like I don't think a library or a school is going to want to invest in something that they have to like fiddle with, right? Like
They were
they're not,
in the prosumer market basically. Like the old stuff that was marketed at libraries and schools would be like $3,000 to $8,000 kind of deal.
so now you have an option that's reasonably cheaper and still probably does the job.
Yeah, all those being American prices, like a Bamboo Labs is half the price and better than those $3,000 to $8,000 options were.
Okay. American prices makes you dream.
Yeah,
What if,
it's pretty brutal.
what if your dollar wasn't dog shit?
And
Yeah.
it's really tragic reading all the British stuff now, and they have to quote things in American dollars and pounds, and they're basically the same. And you're like, it's rough look, boys.
You lose one, or I guess you win one little war, but barely.
Yeah.
Your whole currency goes down the shitter. Do you have more? I don't really have much else on the consumer side of things. Price, you got
Some
anything else?
interesting stuff on the patents, because there's definitely a case where the professional impeded the consumer in terms of parts, because obviously the FDM printers couldn't even be sold commercially until 2009. But one of the funniest things is that because they patented heated build chambers, so basically until 2021, a 3D printer company was not allowed to put the drive motors outside of the chamber that enclosed the 3D printer bed, which would allow them to heat up that 3D printer bed without damaging the motors. And in the early days, everything was printed out of ABS, which is borderline impossible to print if you don't do this, because ABS is a terrible material to work with. And during the RepRap project, they didn't have heated beds or heated build chambers. They came up with the idea of using PLA, polylactic acid, to 3D print with, and that is basically the gold standard now. I guess PLA Plus is probably the gold standard, where they'll put some additives in to make it stronger and more heat resistant than regular PLA, because regular PLA is a little bit of a flimsy filament. But that pretty much came about by necessity because of this patent. And then what followed that is that even PLA was easier to print on a heated bed. So they started putting resistance heaters on their beds. And then they started putting enclosures with the resistance heater bed passively heating the enclosure so that they didn't violate the patent for the active heating. But it's just this whole workaround. And I mean, to some extent, even the existence of PLA as a 3D printing material is due to this patent that was just held over everybody's head, and they couldn't use the obvious solution.
And now they can. Is that
It can, but it's interesting in that I haven't seen it in anything that's like consumer grade. I haven't been looking at the prosumer stuff recently, like the three. I'd imagine it'll start popping up, or it has cropped up in that sort of like $5,000 range, because it really is a game changer for high-end materials, because you'll be printing something that melts at 350 degrees Fahrenheit. So you want your build chamber then to be somewhere like 280, 290 degrees Fahrenheit. Is it even Fahrenheit? It might be Celsius, or maybe it's even super hot, but I don't think it's Celsius. I think it's Fahrenheit that they measure all these things in. I could have it all wrong. I'll just say degrees. So 350 degree hot end, because that's how the YouTubers say it, and that's why I don't know. And then you need like a 290 degree build chamber to optimize your print strength. So the physics behind that being that if it's too cold, then it cools down quickly, and then that cooling down releases stress that's been built up in the filament rapidly, and then that stress relief causes warping and layer adhesion issues, so that it limits what filaments you can print with. Well, my snap maker, I printed ASA, which is a very hot, not as hot as some, but quite a hot filament. and I had to buy insulation from the hardware store and make a cube to throw around the enclosure so that it would be even hotter. And it was quite the experience.
Yeah, that's something I didn't even think about, is like having the heating, because yeah, you want the plastic at a certain temperature. All
Yeah,
these things.
and the PLA, the problem that results from that most people will never run into, but I mean, if you put things in your vehicle, you might, where the melting point is usually somewhere around, I know this one's Celsius, somewhere around 55 to 60 degrees Celsius. So like you put that in the dash of your car as like a bobblehead or something, and you come back and your bobblehead probably won't bobble anymore. It's going to be a little warped. If it's like a 40-degree day out.
Gets cooked in the car, yeah. Jeez.
Yeah. It's about the only place where it's a problem, but it is not uncommon to have car accessories 3D printed. So that's where people will still use ASA or ABS because they're a lot more heat resistant.
Yeah, I guess the other thing is like one of the things that seems, I guess, an impediment to further adoption of 3D printers at home, in my opinion, is the noise. I know that a lot of
that's one. Interestingly, the previous generation, like the Mark III gold standard versus the Bamboo Labs, the Mark III was not bad, and it was especially bearable if you built an enclosure for it, which are a million designs for, because it was king of the crop for 5 years. People came up with every type of enclosure you could imagine. And once you put an enclosure on it, very bearable. You could definitely be in the same room. The Bamboo Labs, though, it's an incredibly fast printer. I think the Core XY system, which is to say the movement system it uses, that's fundamentally different than the Mark III. The Bamboo Labs is a noisy lad. Like, it is enclosed, and it is probably 2 times as loud as my enclosed Snapmaker, which would be using a similar system to the Prusa. But the Prusa was noted for its relative silence, even among its competitors, just because of the high tolerances and build quality. But that has sort of been sacrificed in pursuit of speed. Although the Bamboo Lab does have a quiet mode where it slows down its operation to like 30% speed to make it quieter, but it's still not particularly quiet.
Yeah, because it's just like, I don't know how many people have, would have a dedicated space for,
You
printer.
really want an office or somewhere where you can close the door.
Yeah, and it's just like, I think that might be a definite sticking point for a lot of people, is just like not having having a proper place for it. And
you can double enclose the Bamboo Lab. I was throwing a sleeping bag over it to deaden the noise. And I mean, that makes it pretty reasonable. Like, there's solutions, but yeah, the noise is definitely something to consider that a lot of people don't really talk about much. Although when the Bamboo Lab did come out, because people were kind of searching for a negative to point out about it, that was the main negative, I would say, is the noise.
Interesting.
A lot of people were used to the idea that they could be working in the same room as their 3D printer and kind of forget it was there. And then the Bamboo Lab came in and kicked down the door like the Kool-Aid man.
Oh, yeah.
We're printing in here, bitch.
Going fast, and everybody's going to know it.
It actually doesn't need to be that loud. They just make it that way just because it's like a psychological thing. Make it worse to make people think it's better than it truly is. Classic marketing.
Actually, talking about the people who made the Bamboo Lab, it's a cool story that sold me on when they were doing their Kickstarter. I bought it. I was there when it lagged out, and there were only so many slots, and I couldn't get the biggest discount, but I got the second biggest discount. But it was basically a group of engineers from DJI Drones, and they were there when it was a startup, and they were, I think, some of the big players in the startup of DJI, and they basically got sick of the big corporate culture. They didn't find it as fun anymore, so they just got the band back together and decided to do a new startup, and they'd been working with 3D printers when they were doing their drone startup, and they figured they could revolutionize the industry because they had the know-how and the engineering expertise, and they basically did. Like, it's really quite an interesting story. These guys going to drones, revolutionizing the industry, and then kind of we've done our work here is done, and then going and revolutionizing FDM 3D printing.
Just a bunch of brilliant engineers doing brilliant engineer things.
Yeah,
Not made for the corporate grind.
Yeah. Well, you need
And,
those guys, though. They drive everything forward.
it's kind of unfortunate for the competitors to Bamboo Labs, which would be Prusa's Mark IV and the Anchor Make M5, because Anchor and Prusa would have had a fairly substantial step forward with their printers in terms of speed and quality, but they came out after the Bamboo Labs, so instead of being a step forward, they're now slightly below the bar that's been set, although the Anchor is the price point is better substantially, so it may find a good position as an entry-level printer. And then the Prusa is a Prusa, so it has great customer support, a great community, and I'm sure they're going to sell a ton of them because it's just an improved Mark III. But instead of being king of the roost like they've been for 5 years, they're now in competition, and based on the stats, it's not looking too hot for them. Although their large form 3D printer, the Prusa Max, is it? I can't even remember what they called it now. But they've come up with 2 new printers here, and the large form one is incredibly interesting because it has the ability to attach 5 tool heads separately, and then it will change between the tool heads as it's printing, such that you can do different colors, different materials, or in a long ways down the line, I'd imagine, but you could potentially do something like a CNC tool head similar to a snap maker. But I don't think there'd be support for that in the immediate future because they're still working on getting the kinks out of their existing system.
I guess as like someone not really in the 3D print world, it does. I guess the impression I get is like there's still a lot of innovating and like improvements going on, which is nice to see. Because like one day maybe I will get into it, but it would be much more attractive. Like I guess the current generation of printers is much more attractive to me than like say the
previous.
Like the prior approach of like the low cost kind of do it yourself setup is just holds no appeal to someone like me. So it's nice to see like I think $2,000 Canadian or whatever, like maybe it'd have to come down a bit before someone like me would be into it, but like it seems like that's kind of like the trend, right? Like we probably will get maybe a $500 to $1,000 machine that does everything quite well, and like
even the Bamboo Labs, they came out with the stripped down version that does the basic stuff as well as the carbon or as the X1, which they called the P1P, and that's more in the range of $1,000 Canadian already. And for someone getting into 3D printing, that would be very tempting because it'll do all your simple stuff and kind of show you the ropes. And then, of course, the M5 is, I think, $750 Canadian. So
yeah, that's definitely like much more tempting. Like $1,000 price point that does everything you want it to do as like just a regular Joe.
I think as much as the race to the bottom in the last generation was bad, that if they get to that price point that they hit in the last generation, which was about $250 US or $350 Canadian for the capabilities of, pretty close to a $1,000 printer could be had for $350, like depending on the quality you wanted. Yeah, if they can push down these sort of results in the next 5 years to being $350, $400, I think that'll be the big. Basically sub $500, I think, will be a huge entry point.
I guess on the consumer side of things, with the possibility of much more printers once they get the price and the usability kind of tuned in. I think there's the one topic we did run into that seems to be worth mentioning is like 3D printed guns, because I don't know, it gets a lot of obviously. That seems to be
news.
It gets a lot of play in the press.
And also just like negative attention for 3D printers. Like, like why shouldn't, like basically like the main
got a
reason
license
why.
For that printer?
Yeah, exactly. Is like 3D printing guns. And I guess my quick like 30-second summary on what I kind of came to see about 3D printing guns is like it's a lot harder than it looks or sounds, and it's probably not even worth like spending government money on looking into it very closely because like if someone's smart enough and motivated enough and to do that, they probably could have sourced an illegal gun just easier. Like,
Yeah.
I don't know, like it just seems like a very odd concern given like illegal
Especially
guns
in America, like
well
given
America
like the
is not
amount of guns
illegal.
and the ease of which you're able to get an illegal gun if you're a person in the States. Like it's not that hard comparatively. Like, you know, if you're in a place that is way more controlled, then maybe. But even then, you have the issue of like bullets to contend with. Like if you're in that controlled of a country for firearms, like you still have to get the bullets. So
Mhm.
Well, and there are people that do make their own bullets and their own 3D printed guns, but again, it's like it's such a like small percentage of people that actually have the and combination of dedication and intelligence and know how to like make something like that work. It just seems like I don't know.
Well, I think
far easier just to go smuggle it in from another country or something.
it's the 3D printed guns as they are now, I think are a fairly valid concern because what most people call a 3D printed gun now is a fairly straightforward lower receiver that can then mount rails and all the parts of a regular gun, and only that lower receiver is legally considered a gun. And by fairly straightforward, I mean an intelligent person with a week to work on this job uninterrupted. Like it should be an achievable task. But what the government is doing in Canada and doesn't receive any press because it's not the interesting thing is just starting to find those other parts of the firearm that are all required to make this an operational gun as firearms that require a license to purchase. Well, as firearm parts, but requiring a license to purchase those firearm parts. So, for instance, in Canada, there have been two interesting busts. The one being a guy that was 3D printing these lowers and ordering the parts kits online to complete them into guns, which it was probably the easiest bust in history. I don't think the guy even had a firearms license. So why does he need a bunch of parts for firearms? Seems suspicious. And then another one in Toronto where the people weren't even 3D printing, but this is the same sort of example in that they were buying pellet guns that would accept regular gun pieces. And they weren't built to the quality standards of a real handgun, but they would shoot 10, 20 shots, no problem, which is all a gangster needs. And then they would go to the store in Toronto and they would buy a bunch of parts kits to build up pistols that weren't legally firearms. And eventually it got flagged because they were buying their pellet guns and their parts kits from the same store. And they thought this was an odd purchasing habit. But they made about 60 guns that way. And then the craziest example that was probably the most practical in Canada was somebody just started a metalworking shop that they called a paintball factory. It got a bunch of legal employees, ran a legal business, and had them making submachine guns instead of paintball guns. And they ran that for, I think, a year and a half before one of the employees realized they weren't making paintball guns and told the police.
what a
Yeah,
snitch.
well, that doesn't speak too highly of the other employees. There's just like
They didn't figure it out.
this doesn't seem like anything.
Well, you just
that would
think of
go-
the average city person, how much they know about guns. I could see it. It seems reasonable that they wouldn't understand. They
I
were making
mean,
guns.
yeah, fair enough, but Jesus Christ, it's like, oh, yeah, none
It's
of
a
these.
rather small barrel for paintball.
There's no hopper, there's no CO2, like none of what a paintball gun needs, and everything that a real gun needs. Very odd.
But yeah, like it's definitely with the definition that a 3D printed gun is the lower, that then all the other parts of the gun are just regular gun parts. It's getting to the point where it is becoming more and more straightforward to do it with the improvements in 3D printers. But I think the legislation changes are going to address that fairly comprehensively. And then you run into the issue of real 3D printed guns where it's completely DIY. And those I don't think will ever be outside the realm of dedicated, intelligent individuals who, if people like that become criminals, they're like the Unabomber. It's a big problem, and no matter what you do,
Yeah, that Hubbard's was making that same point. It's like the level of sophistication required to
if you're going
build
to
those 3D
pipes,
printed guns. Like they're going to figure out. It doesn't matter what rules you put in place. They're going to figure out a way to create weapons and harm people because they're like there's nothing. Like
if they wanted to do harm, I'm just saying. I guess my point would be that like someone like that, it just has 7 other different methods of causing harm that would be easier and more effective if they wanted to cause harm.
Yeah,
like,
exactly.
If they just
it's
want to make the gun for the sake of having a gun because they have a ideological position that puts them in the in the mindset of having a gun is a good thing. Like again, like I don't think it's worth like worrying about that edge case in terms of regulating 3D printing.
Yeah, exactly. It's like you're going to crush an industry and a hobby set for zero gain, and you'll wind up like damaging what could be not like years of development that are extremely beneficial in many other areas, and you save no lives and do no societal good with that, which is par for the course for a lot of regulations and regulators.
Well, the impression that you get from like some of the coverage is like that you can buy like a $500 3D printer and some plastic, and then somehow a gun
appears.
Yeah, and a gun that you can like a fully automatic AK-47, and you're going to be able to go mow down an entire mall full of people. It's like, no, that's not how these things work.
And as far as I know, like there isn't any like 3D gun designs that don't have metal parts, unless
the furthest ever was the OG, and you've seen it if you've seen any picture of a 3D printed gun, because it is all plastic except for a nail that's used as the firing pin.
Is that the Israeli one?
No, it's the Liberator. It shoots a 22 long rifle, and the guy took like a year to design it or more. And he said the first time it ever fired successfully without blowing up in his hand, he got to the point where catastrophic failures when he test firing it weren't hitting the operator, so he felt safe firing it from his own hand.
Yeah, his guys like gonna.
And yeah, he got on BBC to show off his gun because it was the latest news story, and that was the first time he ever successfully fired it. But it was all plastic except for the firing pin, which meant that it barely functioned.
Yeah, exactly. And it's
22 long rifle, which is very unlikely to kill somebody. It's a lot less dangerous than a knife.
And how many shots can you fire before the thing literally falls apart?
If you're lucky, 1.
Yeah, exactly. It's like, okay, you missed the first shot, now the gun's dead, and you're getting tackled.
Like, I feel like
just use a knife.
You have better luck. Well, if you want to just fire, you have better luck just getting like a metal tube and a fucking
Japanese Prime Minister assassination tool.
That's just like an easier thing to use than a fucking plastic gun that you like. Again, which is like what I'm saying is the problem is like the perception is you can print like a replica of an actual gun.
Yeah, and it's going to be basically maybe not quite as good as the real thing, but good enough that you could use it for a full spree.
And it's like it's just not.
Yeah, it's not even remotely close to the truth. Because I went on a bit of a deep dive on these 3D printed guns, and the guys that I saw they had been spending years developing these things, like they could get they still had to put a ton of metal parts in them, and they would jam like halfway through firing off a clip. And it's like,
the people who've like really dedicated themselves to it can make reliable firearms, but they all use real firearms parts made of metal, because if you're going super homemade, getting a pipe and trying to rifle it yourself, it just does not result in a firearm that's even going to be enjoyable to shoot. It's so inaccurate. Even the ones using real firearm components, you're often to firearms people, they're like 5 to 6 MOA is about as good as I've seen, and for non-firearms people, that means at 100 yards, you'll be shooting in about a 6-inch group, which makes it interesting to shoot, but it's not going to be the most fun to take out and, practice with, because it's really not that functional of a firearm. It's still like, even on these really high-end ones that cycle all the time and they hold up to 1,000 rounds, and they're made with parts from real AR-15s for the functional metal components. Even then, you are running into the issue that they just aren't very accurate.
Yeah, it makes them highly ineffective. And if you are a person who is looking to cause mayhem and destruction, it's like and you're willing to dedicate a year of figuring it out, there's so many better ways that, again, cannot be regulated. So the regulation is just, it's just a pointless thing.
Well, it's just, it's definitely a net negative in terms of like just the cost benefit analysis of getting too deeply into trying to regulate it. I think
like you're wasting
future,
tons of resources that would be better spent elsewhere.
Like metal 3D printing is going to be, if that ever gets consumer viable, that might be a bit more tricky in terms of regulating stuff like that, because I think then you can make the argument that a lot more interesting,
you might be able to actually develop
interesting designs come available in terms of guns and bombs and all sorts of things. Like, I think just much more dangerous, but plastic really doesn't seem like a material.
And a lot of that metal, like I was looking into the metal printing, and you really need like a proper setup that's extremely expensive. Now, eventually the metal printing might become...
Well, that's what I mean. Like right now, it's just not a thing like metal printing is not a thing worth worrying about.
Yeah, and it really, from what I can see, it's still a long ways off. Like to the point where, anybody can just go purchase a $1,000 to $3,000 metal printer that's going to produce pretty high quality designs. Like a lot of the metal printing is still pretty scuffed.
Possible, just given the stuff involved, but you never know.
If you just throw some buzzwords in, then it's all possible.
But
AI,
I could see
facilitated synergy with onshoring, friendshoring, blah blah blah. Then then $200 metal printers are possible.
I could definitely see metal printers coming down to like the $20,000, $30,000 range in like the next decade. But
I think the concern that you start to run into is just like gangs that, you know what I mean? Like,
because you get one smart guy in the gang and he makes 20, 30, 40 pistols.
Or you just get a smart criminal organization that decides that now they're no longer, buying and smuggling guns. They're
just going to Shinrikyo.
Yeah, then that becomes a bit more feasible with, if you had it only costs you a couple $100,000 in manufacturing capabilities, and it's easy to source it all. Then that, I think, that does become concerning.
But again, it's like you already have pretty big concerns with gangs of that magnitude in the first place. Like, throwing in regulations is probably not going to be the big difference maker, because they're already this massive outfit that you probably have, like
I think you could see regulations around just keeping kind of close tabs on metal 3D printers in terms of where they're sold to and who has them and stuff. Like, I could see that as
like commercial like large scale commercial viable ones. It's like, that does make sense, but
I think the interesting thing isn't so much Canada and the US, because it would affect Canada and the US, but I mean, there's so many criminal guns. But places like Japan or Germany, like where the gun control is incredible, that's where as you're going to go from like Japan, for instance, it's almost impossible to acquire an illegal gun, like you're basically in the Yakuza for sure at that point. It's like their police officers don't even carry firearms to the point where you could have proliferation of guns domestically, where like the proliferation of guns has already happened in North America.
Yeah, exactly. It's not a concern for a place like Canada or America
It could make attempting to control them much more difficult, and like it might increase the numbers, but it's not going to be like a qualitative change like a country like Japan or Germany.
Yeah, well, there were, like I mentioned, Om Shinrikyo. That was a death cult in Japan in the 90s. They actually were the sarin gas attack perpetrators in Tokyo, and they actually had a AK-47 manufacturing facility because they were like $1 billion outfit. And like to your point, like there is kind of precedent in Japan specifically for that, right? And if they get some pretty heavy duty, but of course, like they were trying to build AK-47s and through normal means, right, without having any of the prerequisite.
I used to have it remembered, but I think an AK-47 requires like 140 motions on a CNC machine. Like it's a very simple.
Yeah, it's still a simple gun, but like setting up an entire manufacturing plant turns out not to be the most simple thing to do, right? So they were trying, and if all you need is you just buy the machines for a couple $100,000, buy the material input, and then just download the 3D model and just start run them off and then put them together, you could actually cause some problems. What's that?
We're already at that. When you say a couple $100,000, we're already at that point. Like that's absolutely achievable for $1 million. Like you could have a metal 3D printer going for $1 million.
Yeah, but I still think like 3D printing the guns is with a metal printer probably completely doable now, but I don't think it'd be as simple as just downloading the file and just plug and play.
No.
I think there would be a huge learning curve there, but you might still have some organization that decides like, yep, go for it.
Well, even Om Shinrikyo with like traditional manufacturing, they struggled very. It was very difficult for them to get like functioning guns produced because
they never. I don't think they ever built like a fully functioning AK. As far as I remember,
a lot harder than it looks to make shit.
Yeah.
Well, that's one of the reasons you have like firearms manufacturing. That's another interesting aspect on the legal side is even the firearms manufacturing, because right now it's basically controlled by legacy companies and even legacy countries for firearms manufacturing. That kind of freezes out a lot of potential innovation because the cost of innovation is so high. So, like the latest player in the world firearms game, at least in Canada, is Turkey, because Turkey has their firearms industry dating back to the Ottoman Empire, and they still have all the technology to make firearms, and they've been making firearms for Italy for forever, and then Italy's been sort of rebadging them and selling them as Italian guns, and then the Turkish companies finally realized that nobody cares about the Italian name brands. Well, consumers don't care enough that they are absolutely willing to buy the Turkish ones for half the price, which gives the Turkish firearms manufacturers a better cut of the deal anyway. So, but that's like the sort of system that exists in the United States. Most of the firearms manufacturing, almost all the firearms manufacturing until about 10 years ago, was in the northeastern United States, because that's where it was before the United States Civil War. And like they've only started moving them in the last 10 years, with the states in the north being way more anti-business and the states in the south being very pro-business and willing to give good deals to any companies that move there. Like firearms manufacturing is incredibly glacial at the rate that it moves. It just does not there's not rapid prototyping, there's not very much innovation, there's not a lot of experimentation, and 3D printing could absolutely upend that business model.
Just not for people at home.
Hopefully.
They'll be banned from it.
But it's an interesting thing with I was thinking about this recently, because even at $1 million, it's way cheaper to try and get a 3D printer for metal and do your gun prototyping. But I think it's still, there's so much inertia that their existing manufacturing facilities are way more cost effective, and nobody really wants to take the risk on millions of dollars to get these 3D printers and see if consumers want new guns or weird guns or anything like that. But it's coming.
Yeah, eventually somebody's gonna try it.
I'd also assume like a big problem that 3D printing faces in guns and a lot of other industries that are high risk, high liability is just like getting, you know, the
Getting
kind
the
of like,
metallurgy right.
and getting the regulatory approval. Like,
Oh yeah.
like just I mean that's been a problem in terms of like innovating with like electronics in say the automotive space. Is like car manufacturers use what we'd consider like very old, outdated chips and stuff and electronics, not because it's the most economical, although that's part of it, but a big part of it is just like they don't want to go through the regulatory hoops of getting a new thing approved and worrying about the reliability of the, you know, the most cutting edge electronics. It's just like this particular item was approved, it works, it doesn't need to be better. Like there's no point spending millions and millions of dollars like getting something new approved, getting something new tested, and making sure it's reliable enough to meet all the safety and, you know, reliability standards that they need for the to, you know, not get sued out of the fucking existence. And it's just
yeah. And then another thing with 3D printing is you need to there's a few different styles of doing the metal 3D printing, and they all have their pros and cons, but it's a little too esoteric to get into. But the basic metallurgy is something you have to take into account as well. Like, is it going to end up making a metal that's strong enough to withstand the chamber pressures involved in a firearm? Because it's not going to have the same structure necessarily as milled metal or stamped metal.
No, they definitely don't. I was watching videos on that, and it's certainly a different. It's a very different structure to the underlying like lattice.
which means again they'll need,
You have to,
you know, like so many steel products have you know, industry standards and like grade and specification standards that have been like
they've been
you know,
around for decades, and
yeah,
exactly.
decades
And
and
you have to
decades
reinvent
of,
all of that.
well, you don't necessarily have to reinvent it, but it's like it will take quite a big you know, cost savings or benefit for them to start, you know, jumping through those hoops and spending the money to jump through those hoops.
Yeah, exactly.
So there's a lot of hoops in those industries that have to be jumped through. So again, like the benefit has to like really start to build up such that it's just like, okay, this definitely makes sense. Like this is going to save us so much money that
we won't know what to do with it.
Yeah, we'll deal with the headache of going through all this bullshit. Like it's not, yeah, it takes more than just like a marginal improvement in a lot of those industries. Is there anything else we want to jump on for 3D printing?
Well, I think
Not
the
for
last
me.
thing that I would bring up is the sort of cottage industry perspective, but the very small cottage industry of people like selling stuff online on Etsy or Facebook Marketplace or eBay. I've been in that rabbit hole recently, and it seems very interesting in the fact that, you know, before the Bamboo Lab era, if you wanted to sell anything online, you basically needed 3 or 4 printers in case you got any reasonable amount of demand. But I think in the Bamboo Lab and other fast printer eras, I think it is probably achievable for most people if they want to try it out. And if they want to get a 3D printer, it's achievable for them to try out selling things online because they'll have the production capability with these faster printers with just even a single printer to sell some small volumes.
Yeah, that's such a big, like, how quick was that transition between those two? Like what was the step change? Like 4 times?
I'd say
And over
like
how
in
many years did that occur?
In
Because it is quite
practice,
a
you're
jump.
getting about 4 times faster. But it happened in the do-it-yourself incrementally because that would be the Voron printer kits. And the Voron is still, if you make it yourself and you kit it out, you can still get it faster than the Bamboo X1. But in the commercial market where you like a consumer could go out and buy a printer, you went basically overnight from the Ender 3 or the Prusa Mark 3 to the Bamboo Lab X1, and you had a 4 times speed increase,
That's
and
pretty
potentially
crazy.
higher depending on your like what you're willing to sacrifice for speed, but like 4 times higher at least for the same quality of part. So that was pretty much an overnight change if you were only in the market for buying a printer, because the technology that underlay it was being developed by do-it-yourselfers, and that didn't really see the commercial light until Bamboo Labs. I'm probably missing some higher end printers that would have used the technology though, to be fair. I'm just talking from the very like sub $2,000 market.
Yeah, I think that'll be fun to watch, like just all the different things people try and fail with and screw around and offer. Like there's definitely gonna be a huge cottage industry of just selling new things that would have never been possible before.
Yeah.
I don't know how like important those things will be. Like some of them will, like because it's it is at end of the day for like that kind of size. You're talking about kind of more or less smallish plastic parts, right?
Yeah. Like, I mean, the obvious one that I saw is the, cordless drills and such. They have batteries. You 3D print a little plastic bracket that hangs under your shelf or on your wall, and you put the battery into that bracket when you're not using it. And like the injection molded versions of those sell for $5 a part, and they're made in Britain and shipped over to North America. I mean, they cost like 50 cents maybe to make on your 3D printer.
Yeah, there's gonna be all sorts of things like that, which will be convenient, right? Like,
I think a ton of that sort of like little organizational stuff, because so many people with their 3D printers have just like spent way too much time organizing everything they have.
I'm for it. I like little organizational stuff, so
Yeah.
I'll
Yeah,
be
that'd actually be
scouring
pretty
Etsy.
sweet. I'm not gonna spend $2,000 on that.
It's unreal on Etsy how many people are on their 3D printers, but it's still like it's going to explode. Like it'll probably be 10 times higher in 2 years.
Yeah, we'll see. We'll see how whether or not how much net benefit there is.
Yeah.
Be interesting. Is there anything else we want to throw in, or I'm personally tapped out.
That's it for me.
Yeah,
All right.
Seems good.
Well, let's wrap her there.
All right, thanks for
Peace.
listening. Peace.